pay 25% tariff. Why? Okay, what will we do? Buy Canada, and what will we do next? Buy less. We recycle more, right? So is there a possibility? No. Okay, so do not worry. Okay, I'm trained to fire all sorts of military weapons in my national service days, and I'm a sniper. Okay, I will gun the burger down and you know. Okay. So don't worry. Don't let the media clear your mind. Donald Trump is coming. Are we clear? Clear. When do you panic? When I leave the country, you all can leave. Are we clear? Otherwise, don't go anywhere. Are we clear? Okay? Right. I think that is better than thinking any moment, right? Okay, so don't worry. We will be well. Now, coming back to here. Okay, so stay at ease, focus on 303, design something spectacular, okay, that the Americans can design. So when we have this, okay, in order to apply this formula, there are a few things that we have to know. One, we put a point down there because this is the center of curvature. Okay, so based on the center of curvature, we know anything that is pointing towards the center of curvature, y is what? Positive. Any point that's below or pointing away from pointing away from the center of curvature is what? Is negative. Agree or disagree? Right? You all agree now. Okay. So when that's the case, if we will have a point at the top, which is called our alpha point, and another point over here known as our I, right? So for point alpha, y is going to be what? Positive. For point I, y is going to be what? Negative. So from here, when we apply stress x is equal to alpha, stress x at alpha is equal to minus mz over izz multiplied by positive y. Okay, so this we know will be negative. It means it's under what? Compression. On the other point, this is stress y and stress x at point I now. So this is minus mz over izz. Now this is equal to minus what? Minus y. Negative and negative will give you a positive. This is equal to what? Tensor. So we know, right? The stress I is going to be positive, and we know that stress alpha is going to be what? Negative. Issue an easier problem. The problem with this technique is you have to remember stress x is equal to what? Minus. Yeah, game over. The next thing is you have to know y is dependent on the what? Center of what? Curvature. Y equal to center of curvature is positive, away is negative. I'll teach you something easier. Where this thing is bent, this is moment about z. The head of the moment vector is always under compression. The tail end is always under what? Tensor.
That's an easier way. Now you can forget the y. What is y positive, y negative does not matter. The head, okay, so I'll draw down here. Okay, so the moment vector, right, for the moment vector, the head is always what? Compression. And the tail is always what? Tensile. So this is what we call the tail, and this is what we call the head. And in terms of stress, this is always negative. In terms of stress, this is always what? Positive. That's all. No need to remember. Mx is equal to minus my over. Now watch this. Ruler now. I brought mine. Okay. In order to get this way, the moment vector has to what? Come down. Yes or no? Can anyone tell me the top is under tension or compression? The bottom is under? Do you need to like, okay, center of curvature pointing towards y is positive minus mx? No. You can what? Visualize. Are we clear? Only when you visualize, you can always what? Remember. As an engineer, what do you learn? Always carry a ruler around. Yes or no? On a cantilever beam, now I put it down where we fail. At the point that I hold. And what's the slope? 0. Be clear. Okay. So from here, we can very quickly define what is a tensile, when is it a tensile loading, and when is it in compression loading. Are we clear? Okay, so this is so much of an easier way that you can remember rather than being fixated on the formula. Okay, always remember to what? Visualize, 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 visualize. Okay, now the next thing I want to highlight, when do we classify when is it unsymmetrical? Okay, so now I'm going to draw another structure. Oh, I need to draw. So now, what we have now is we do have over here this is our moment at y, okay? And then this is going to be a moment about z, okay? I'm now going to call the point alpha, beta, I, and j, okay? And then the distance from here to here, the distance is what we call, this is our distance A, and the distance from here to here, our distance B. Okay. So a good thing to do is we are going to use our right hand rule. And I want you to do this. Okay. If this is our moment, right, and we use our right hand rule, this is known as compression. This is known as what? Tensile. Okay. So when we have that, I'm going to rotate. Rotate again. For you, you just take a piece of paper and rotate. Are we clear? Okay. So now what you can see now, okay, we are going to apply, if you look at MZ, right, or MY, right? So we know for MY, right, if the rotation is this way, and for MZ, right, the MZ now, right, the rotation is coming down this way. Yes or no? So for MY, we know that over this side is compression, right? And then on the other side, MY is under what? Tensile. I'll use a different color for MZ. We know on MZ, right? This is compression. For MZ, this is equal to what? Tensile. So now if we were to write the stress X at point alpha, right, is equal to what? Okay, so it's equal to positive my over Iyy multiplied by z, right? And then for mz is also positive mz over izz multiplied by y. Okay. Then if now we were to change, now we know that, okay, so my, okay, so we know my, so we know that this is equal to b over 2. Y, no, x is not b over 2. X is equal a over 2. And this is b over 2. And then if we have stress x, okay, normal stress in the x direction in beta now. Now this was, so my will be under compression. And then in the z will be under tensile. Now this is still the same, a over 2. This is equal to b over 2. So now the positive and negative is controlled by the vector of your bending moment. We clear? So what we can see down here, that stress x at point alpha is not equal to stress x at point beta. So it's what we call unsymmetrical bending. We clear? Okay. Next week is reading week. Rest well, have fun. Okay, good stress. We clear? Come back, stay. If you don't come back, I'll come after you. Are we clear? Okay, have a good reading week.
Eugene, when do you think the grades are gonna get posted?